In this video, we're going to talk about how to write net ionic equations. So let's consider the reaction between aqueous lead-2 nitrate and aqueous potassium chloride. Now, the first thing that you need to do is you need to predict the products of this chemical reaction. That's the first thing. Now, what we have here is a double replacement reaction. Lead is going to pair up with chlorine, and potassium is going to pair up with nitrate. Potassium has a positive 1 charge, nitrate has a negative 1 charge. If the magnitude of the charges are the same, then you can combine those ions in a 1-to-1 ratio. So one of the products will be KNO3. Now the other product, we need to pair up lead and chloride. Lead has a positive 2 charge, and we could tell based on how many nitrate ions are attached to it. Each nitrate ion has a -1 charge, and there's 2 of them. So to neutralize the 2 nitrate ions, lead has to have a positive 2 charge. Chloride has a -1 charge. So when you combine these two, it's going to be lead1Cl2, or basically just PbCl2. Now we need to write the phases of the products. Potassium nitrate, is it soluble or insoluble? So hopefully you're familiar with your solubility rules. Nitrates are always soluble, so therefore this is going to be an aqueous phase. Now what about lead-2 chloride? Does that dissolve in water, or is it insoluble in water? Lead-2 chloride is insoluble. The halides, chloride, bromide, iodide, they're soluble with everything except lead, silver, and mercury. So what we have here is a solid product. Now our next step is to balance the formula equation that we have here. So notice that we have 2 nitrate ions on the left side. So therefore we need to put a 2 in front of KNO3. But now we have 2 potassium atoms on the right side, so we got to put a 2 in front of KCl. And we could put a 1 in front of the other ones. So now we have a balanced formula equation. Now whenever you mix 2 aqueous solutions, and if you get a solid product, then this reaction is not only a double replacement reaction, but it's also called a precipitation reaction. So keep that in mind. Now once we have our balanced formula equation, we need to write the total ionic equation. And the way to do that is you need to identify every substance that is in the aqueous phase and separate them into ions. The substance that is in a solid or liquid phase, or anything else other than the aqueous phase, you want to rewrite it exactly the way it is. So lead-2 nitrate, we're going to have to decompose it into ions. So we have a Pb+2 ion and 2 nitrate ions. Next, we need to break up KCl. So we're going to have 2 potassium plus ions and 2 chloride ions. And then potassium nitrate is also in the aqueous phase, so that's 2K plus 2NO3. And this, we're not going to change it. We're just going to rewrite it as PbCl2 in the solid phase. All of the ions that are listed here, they are in the aqueous phase. So you can write AQ for all of them if you want to. Now the next step that we need to do is we need to eliminate the spectator ions. What are the spectator ions in the total ionic equation? Can you identify them? The spectator ions are those that appear exactly the same on both sides. So potassium is a spectator ion. Nitrate is a spectator ion. Now what you have left over is the net ionic equation. So it's lead-2 plus. By the way, if you're doing one of those online homework assignments, you may have to write Pb as 2 plus instead of +2. I don't know if they're going to change it in time, but when I remember doing these questions for like an online assignment, you have to write it as 2 plus instead of +2. So if you see me writing as plus 2, it's just a habit of mine, but you may have to, your teacher may want you to write it as 2 plus. So just keep that in mind. So we also have 2 chloride ions, and this is going to form PbCl2, solid. So this here is the net ionic equation of this precipitation reaction. So as long as you follow the process, these problems won't be that difficult. You just got to do a few practice problems on it, and you're going to get the hang of it. Let's try another example. This time, it's going to be an acid-base reaction. So we have aqueous sulfuric acid reacting with aqueous sodium hydroxide. Predict the products of this reaction, balance the formula equation, write the total ionic equation, and then the net ionic equation, and also identify the spectral ions. Feel free to pause the video if you want to try this. So this is another double replacement reaction. It's also called an acid-base neutralization reaction. Now, just like the last example, we're going to pair up the first part with the last part. And the two parts in the middle, the sodium and the sulfate ions, will get together. Now, whenever you mix hydrogen with hydroxide, it will always create H2O. So in any strong acid, strong base neutralization reaction, you're always going to get water as a product. And water is in a liquid state. Now, what about pairing up sodium and sulfate? What is the chemical formula of sodium sulfate? Sodium is an alkali metal in group 1. Sulfate is a polyatomic ion with a -2 charge. So to write the formula is going to be Na2SO4. So that's sodium sulfate. Now go ahead and balance the chemical reaction. So how can we balance this reaction? Well, for one thing, we have 2 sodium atoms on the right side, so we got to put a 2 in front of NaOH. And now notice that we have a total of 4 hydrogen atoms, 2 from NaOH and 2 from sulfuric acid. So therefore, to balance the hydrogen atoms, we need a 2 in front of water. And so now the chemical reaction is balanced. Sodium sulfate, is it soluble or insoluble? All of the alkali metals found in group 1 are soluble, so this is in the aqueous phase. So now we can write the total ionic equation. So keep in mind, in order to do this, everything that's in the aqueous phase, we need to separate into ions. So let's start with sulfuric acid. It has 2 hydrogen ions and 1 sulfate ion. Next, let's move on to sodium hydroxide. So we have 2 sodium ions, don't forget there's a 2 in front, and 2 hydroxide ions. Now let's move on to sodium sulfate. There's 2 sodium ions and 1 sulfate ion. So all of these ions, keep in mind, are in the aqueous phase. So you got to write AQ for each one. Now water is not an aqueous phase, it's a liquid. So therefore we're not going to separate it into ions. We're just going to leave it like this. So this is the total ionic equation. Now what are the spectator ions in this example? What ions appear to be the same on both sides of this equation? Well, we have the sodium ions, they appear exactly the same, and also the sulfate ions. So what we have left over is 2H plus 2OH, which produces 2 water molecules. Now notice that we could divide everything by 2. We can reduce the coefficients, and if you can, you should. So the balance net ionic equation, it's going to be H plus OH minus produces 1 water molecule. So H plus is in the aqueous phase, hydroxide is in the aqueous phase, and water is in the liquid phase. So this is our balanced net ionic equation. So hopefully these two examples will help you to write net ionic equations for any double replacement reaction. So that's it for this video. Thanks for watching, and if you want to find more of my chemistry videos, just feel free to check out my channel. You can find chemistry tutorials, physics, calculus, algebra, and a lot of common subjects that are taught in high school and in college. So thanks for watching.